So let's proceed and then do some examples. As I said earlier on, we are focusing on the product of a cos and a sine where the n or the powers of both sine and then cos is more than 1, and then the power of the sine is an odd one. So let's take the integral of cos power 2 of x sine power 3 of x dx. For instance, to convert this integral to integral of the form integral of cos of maybe power n of x sine x dx, we need to rewrite this sine function over here in a form in which we will be allowed to write all the functions in one common term. For instance, the sine power 3 of x is equal to, we can rewrite it as sine power 2 of x multiplied by sine of x. As you can see here, when we multiply it back, we are going to get sine power 3 of x, which is actually the same as this. And based on this, we are all aware that the trigonometric identity sine square of x plus cos square of x is equal to 1. And later on, we will show you why it is 1 when I do a full tutorial on trigonometric identities. So based on this identity, we can say that then our sine square x is equal to 1 minus cos square of x. So one trick that I will show you here is that whenever you get either a cos or a sine function in the highest power and you want to reduce it down, make sure you use this trigonometric identity. And then based on that, if the sine, for example, if the sine is having a power of 5, you need to bring one outside, one sine outside. So we are going to get sine power 4 of x multiplied by additional sine of x. So when you multiply by additional sine of x like this, now we get the sine function to be an even power. And since we have it as an even power, we can also rewrite it as sine square of x all power 2 multiplied by sine of x. So in this way, we will be able to employ this trigonometric identity, and then we substitute it over here, right? So in this case, we'll be able to use or make use of this trigonometric identity. But we are not yet there yet. So let's concentrate on whatever you want to do before we come to that part. Now, as I said, based on this trigonometric identity, sine square x plus cos square x, which is equal to 1, we can say that our sine square x equal to 1 minus cos square x. So because we have something like this, we can rewrite the function, which is being given as cos power 2 of x sine power 3 of x dx as equal to the integral of cos square of x. As you know, there's a cos square of x here. And then, since you have been able to rewrite this one as this, then we will try and substitute that. So when we substitute that, we are going to get sine to the power 2 of x multiplied by additional sine of x. So if we have its additional sign of x like this, then we can make use of our trigonometric identity over here. Now, inserting our trigonometric identity, we are going to get the integral of cos square of x, and then we substitute it. We are going to into brackets 1 minus cos square of x, and then everything we multiply by sine of x. You have to take note that when you look at whatever we are having now, still we are having another sine function inside, but the goal is to reduce everything in such a way that we will get them in one common term, which is the cos function. And in this case, we can make use of the u substitution over here to aid in our favor. So making use of the u substitution, we can say that let our u equal to cos of x. And the idea is that when we make our u equal to cos of x, and when we differentiate it, remember that everything is in what? Dx. When we differentiate this, we will get sine, and that sign will help us eliminate this one when we do the dx substitution over here. That's the idea. But the issue is when we use maybe u equal to sine of x, when you differentiate it, you are going to get cos of x. And the cos of x cannot cancel all the cos functions over here, which will make your integration very difficult to do. So in that case, we are going to make use of u to be equal to cos of x. And making our u equal to cos of x, we can say that our du dx is equal to minus sine of x. And making the u the subject, we can say that we have our du equal to sine of x dx. And making dx the subject, we can also get dx equal to du over, remember here is negative, sorry. So du over negative sine of x. So now we are having our dx in terms of the u and then sine of x. So the issue is to substitute it back into the original question. So when we substitute it back into the original question, you can see that there will be some cancellations inside. And that cancellation is going to be sine of x. And after that, we are going to be left with only cos functions inside the original question which was given. But take note that we said that let u equal to cos x. So as soon as we say let u equal to cos x, the whole function changes. So now the function becomes u, let me rewrite it so that you can see it well. U squared, because here the cos here is squared, u squared into bracket 1 minus u squared, right? And then when I replace this dx, I'm going to get du over negative sine of what? X. So having du over negative sine of x, remember that we have a sine x here, so multiply also by sine x. Now we can see the cancellation, so this sign will cancel this sign, and now we are going to have everything in terms of u. So having everything in terms of u, we can rewrite it as the integral of negative u squared into bracket 1 minus u squared all du. And we can simplify it further to get integral of negative u squared plus, because negative give us positive, u power 4, and they are all du. You can rearrange it to get your desired one that you want. So in rearranging this expression, you are going to get u power 4 minus u squared all du. Now you can see that whatever expression that you are having here is far simpler than the question, the original question which was given, which is cos square of x multiplied by sine cube of x. And in doing this, I know that everyone can apply the power rule to solve this integral. And in this case, is the integral of u power 4 minus the integral of u squared. And don't forget that they are all du, and here is also du. And doing this, we are going to get u power 4 plus 1 over 4 plus 1 minus u power 2 plus 1 over 2 plus 1. And don't forget that this is an indefinite integral. So since it's an indefinite integral, we need to bring our arbitrary constant of integration, which is what? C. So in simplifying this, you are going to get 1 over 5 u power 5 minus 1 over 3 u power 3 plus c. And don't forget that we said that let u equal to cos of x. So in letting u equal to cos of x, you can replace it, and we are going to get 1 over 5 cos power 5 of x minus 1 over 3 cos power 3 of x plus c. So now the integral of the product of these two functions, which is cos square of x multiplied by sine power 3 of x dx, is now giving us to be 1 over 5 cos power 5 of x minus 1 over 3 cos power 3 of x plus the arbitrary constant of integration, which is what? C. So going on to our next topic, I would like you to give you a similar example to try your hands on, and I will also give you the final answer to check if you are correct or you have done some mistake inside. And this is the question. So this is a trial question. The integral of, or evaluate the integral of cos square of x and then sine square of x. I hope this is very simple for you and you will be able to solve this one with ease without wasting much time. So the final answer that you are supposed to get after you have done solving this question, you are going to get 1 over 3 sine power 3 of x minus 1 over 5 sine power 5 of x plus the arbitrary constant of integration, which is c. Remember that we are dealing with indefinite